Welcome students, Jai Hind. Welcome to my YouTube channel. Students, in my considered opinion, education must be a sort of insurance against any sort of unemployment. But students, at this stage, you need not to bother about employment, unemployment and all those things. The only thing you need to bother is about gaining knowledge in the truest sense. If you are able to gain knowledge, then I can assure you students, no one can deny you from leading a dignified life. That, from my personal experience, I can assure you. So without any sort of botheration, just try acquiring actual knowledge. Not through rote learning, not through cramming anything, not through obtaining marks by any unfair means, but by actually understanding the concepts. You need to have that theoretical concepts, theoretical skills. You need to develop your aptitude. You need to develop your attitude actually. Then no one can stop you from leading you a dignified life. Clear, students? So with that, let's start this session. In the previous lecture, we have discussed dot product or scalar product. Now it's turn. We discuss about cross product, which is also known as vector product, right? So first we'll discuss its definition. How to define cross product? So cross product of any two vectors A and B is represented like this: A vector cross B vector. This is read as cross. So A vector cross B vector. This is the cross product or vector product. Students, it is defined as the product of magnitude of the two vectors and the sign of the smaller angle between them. This will give its magnitude, and the direction of A cross B is perpendicular to the plane containing A vector and B vector, and that's given by right hand thumb rule, which we will discuss. So suppose its direction is given by n cap. This is a unit vector which represents the direction of A vector cross B vector. So students, the cross product of two vectors possesses both magnitude as well as direction, and hence is a vector quantity. Since the cross product of two vectors is a vector quantity, that is the reason why cross product is also known as a vector product. So this part will give its magnitude, and this represents the direction of A vector cross B vector. We will discuss its direction in detail. Which rule is to be applied, that we will discuss, right? So, let's again discuss the definition of the cross product. The cross product of two vectors A and B is defined as the product of magnitude of the two vectors and the sign of the smaller angle between them, and having direction given by n cap. N cap, students, will discuss. It is perpendicular to the plane containing A vector as well as B vector. So this is how cross product is defined. Now n cap, direction is given by right hand thumb rule. It is given by right hand thumb rule. This is the rule which we will be now discussing. Right? This is a very, very important rule. So let's consider case 1. Look, this is a plane. Suppose this is a horizontal plane where A vector and B vector both are lying. Right? This is a horizontal plane. And this is suppose A vector, and let us consider this to be B vector. And we need to determine the direction of A cross B. So the angle is to be measured from A vector to B vector. So the orientation of the angle must be like this. So in this case, right hand thumb rule states that in the right hand, if the fingers curl along the direction of rotation of the vector A towards vector B, vector A towards vector B, then the thumb will point towards the direction of n cap. Clear students? I repeat, right hand thumb rule can be used to determine the direction of the cross product of any two given vectors. That is, that will give us the direction of n cap over here. And this rule states that if in the right hand, if the direction in which the fingers curl represents the direction of rotation of A towards B, or it represents the direction of A vector towards B vector, right? In that case, the thumb points towards the direction of n cap, which in turn will give us the direction of A vector cross B vector, right? So it's like this. The angle is measured from A to B in the anti-clockwise direction. So my fingers are also curling along that direction in the anti-clockwise. The thumb is pointing in the upward direction, perpendicular to this horizontal plane. So this is the direction of n cap, which will represent the direction of A vector cross B vector. So from the diagram it's pretty clear. N cap is perpendicular to the plane containing A vector and B vector. So it must be perpendicular to both A vector as well as B vector. So n cap, it is perpendicular to both A vector as well as it is perpendicular to B vector. Or in other words, n cap is perpendicular to the plane containing A vector and B vector. Clear, students? Now in this case, we have considered A vector cross B vector, right? Angle is measured from A vector to B vector and anti-clockwise direction. Now let's consider case 2. Case 2 is, students, will consider B cross A. This is a horizontal plane. Suppose this is a horizontal plane, right? And we'll consider this is B vector, and let us consider this to be A vector. Now we'll consider B cross A. So students, remember, we need to consider the direction of rotation of B towards A. So it will be in the clockwise direction. So let's make use of this rule again. This is my right hand, isn't it? So the fingers must curl along the direction of rotation of B towards A. That is in the clockwise direction, like this, B to A, like this. So the thumb is pointing in the downward direction. The thumb, which will be perpendicular to the horizontal plane and in the downward direction, will represent n cap, which in this case will represent the direction of B vector cross A vector, right? So this will be the direction of n cap, which will be B vector cross A vector. Again, it is perpendicular to the plane containing both A vector as well as B vector. So here also the direction n cap is perpendicular to both A vector as well as it is perpendicular to B vector. So whatever be the orientation of the angle, one thing is pretty evident. The direction of n cap must be perpendicular to the plane containing both A vector as well as B vector. Whether it is perpendicular to the plane and in the upward direction or perpendicular to the plane and in the downward direction, it will depend upon the orientation, whether we are measuring the angle in the anti-clockwise direction or in the clockwise direction. Clear, students? So again, I repeat this rule. Right hand thumb rule can be used to determine the direction of the cross product of any two given vectors. Here, it will represent the direction of n cap. This rule states that if in the right hand, the fingers curl along the direction of orientation of the angle, in this case it's in the anti-clockwise direction like this, then the thumb will represent the direction of n cap. In this case, angle is measured from B to A, B cross A. That is the rotation of vector B towards A. So it's in the clockwise direction. So thumb is pointing in the downward direction. That is where the direction of n cap must be. Clear, students? So what do you conclude from these two cases? Observe these two cases very, very carefully. Now A cross B or B cross A, both are not equal. Their directions are different. In this case, the direction of A cross B is in the upward direction. The direction of B cross A is in the downward direction. So from this we conclude that although the magnitude of A cross B must be equal to the magnitude of B cross A, no doubt regarding this. But they are oppositely directed. They are negative vectors of each other, and that will be represented by, actually, in vector form, A vector cross B vector must be equal to minus B vector cross A vector. Now students, look, this equal sign suggests that both A cross B and B cross A are of equal magnitude, and this negative sign suggests that both are oppositely directed. The angle between them is 180 degree. So here A cross B is directed perpendicular to the plane and in the upward direction. Here B cross A is directed perpendicular to the plane and in the downward direction. So basically students, it do not obey commutative law. It is anti-commutative. So vector product do not obey commutative law. Clear? This is one of the basic properties. Okay, before we start discussing the properties along with various examples, once again I must remind you the definition of the vector product. Look students, this is the cross product. The cross product of any two vectors is given in magnitude by the product of magnitude of the two vectors and the sine of the smaller angle between them. Clear? And direction is given by n cap, which is perpendicular to the plane containing both the given vectors, and its direction is given by right hand thumb rule. So that's the appropriate definition of cross product of any two given vectors. Clear students? Now let's discuss some of its very important properties. Let's start with the first property. So students, as we have discussed, cross product do not obey commutative law. It is actually anti-commutative. Okay, so let's discuss its properties one by one. Properties of cross product. Okay, let's start with the first property. It do not obey commutative law. It do not obey commutative law. That is, A vector cross B vector is not equal to B vector cross A vector. So actually it is anti-commutative. So vector product is anti-commutative. It is anti-commutative. So actually just now we have proved A vector cross B vector is equal to minus B vector cross A vector. Just now we have proved it. Equal signs represents the fact that A cross B, B cross A both are of equal magnitude. And this negative sign suggests that the angle between them is 180 degree. That is, they are oppositely directed. So that's the first property. It do not obey commutative law. Second property is it obeys distributive law. Vector product obey distributive law. That is, we'll prove it mathematically. A vector cross B vector plus C vector, it will be equal to A vector cross B vector plus A vector cross C vector. So it does obey distributive law, as was in the case of dot or scalar product. Clear students? So that's the second property. We will try to prove it mathematically as well. Third is, students, as I have told you, cross product is also known as a vector product. Why? Because the cross product of any two given vectors is always a vector quantity. So cross product of two vectors is always a vector quantity. So this is another very important property. I'll give you some examples, although these are the physical quantities which we'll be discussing in a later section, right, in rotational motion, right. There are some properties like torque. Example is torque. Torque is a physical quantity which induces a rotational effect in the body. So it is represented by tau, TAU, this is the symbol. So it is represented by cross product of position vector and force vector. This is position vector, this is force vector. This is the cross product. Both these are vectors and their cross product is also a vector quantity. Torque is a vector quantity. We'll discuss about this physical quantity in the later section, right? Second, we have heard about linear momentum. So in rotational motion, we'll discuss a term angular momentum. It plays the same role as is played by linear momentum in translatory motion. So angular momentum. Angular momentum. It is actually a vector quantity represented by capital letter L. It is given by cross product of position vector and linear momentum. P is the linear momentum, it's a vector quantity. R, it's a position vector, which is again a vector quantity. The cross product of these two vectors is again a vector quantity. Angular momentum is a vector quantity. Clear, friends? Similarly, there are some more examples. Third, linear velocity. It's actually given by omega vector cross r vector. This is angular velocity. This is the radius vector. Both are vectors and their cross product is again a vector quantity. Velocity, as you are aware, it's a vector quantity. Clear, students? Fourth example, acceleration. We are aware of it. It is given by the cross product of angular acceleration and the radius vector. We'll all discuss these terms in rotational motion. So what I mean to say is that the cross product of any two vectors must be always a vector quantity. So that's third important property. So I have given you these examples, right? Okay, fourth. Look, students, if the two vectors are perpendicular to each other, then the magnitude of their cross product would be simply equal to the product of the magnitude of the two given vectors. What I mean to say is that this is A vector, this is B vector. Suppose the angle between them is 90 degrees. So A vector cross B vector. What is its formula? It is AB sine theta. I am talking about magnitude. So avoid n cap, right? Only I am talking about magnitude. So magnitude of A, magnitude of B, sine, angle between them is 90. Sine 90 is 1. So it will be equal to A. So the conclusion is, if the two given vectors are perpendicular to each other, then the magnitude of their cross product is equal to the product of their magnitudes. Clear, students? So this is fourth property. Fifth one, if vectors are collinear. If vectors are collinear. Collinear vectors means, students, the angle must be either 0 degree or 180 degree. As we are aware, collinear vectors are those vectors which may or may not be of equal magnitude, but the condition is they should either act along the straight line in the same direction or in the opposite direction, or they can act in the parallel direction or anti-parallel direction. So the condition for collinear vectors is that the angle between them theta must be either 0 degree or 180 degree, right? In either case, theta is 0 or theta is equal to 180 degree. In either case, sine 0 is 0, also sine 180 degree is 0. So AB sine theta, if we consider cross product, then sine 0 is 0, sine 180 is 0, then the cross product of two collinear vectors is always 0. Therefore, A vector cross B vector, it will be equal to null vector. Isn't it? It's a null vector. If A vector and B vector are collinear. So remember this very important point. If in a numerical, if you are asked that prove that these two given vectors are collinear, then what you are supposed to do is, you are supposed to find the cross product of those two vectors. And if it happens that the result is a null vector, then it will eventually prove that the two given vectors are collinear vectors, right? So the conclusion is, for two vectors A vector and B vector to be collinear, their cross product must be a null vector. So that's again a very, very important property which we'll be making use of in certain numericals, right? Okay, students. Now let's discuss the next property, sixth one. Cross product of a vector with itself, it will always be a null vector, right? So, sixth property. Cross product of a vector with itself is a null vector. It will be a null vector. Why is it so? Because a vector cross a vector between equal vectors, the angle is 0 degree. So it will be magnitude of A multiplied by magnitude of A, sine of the angle between them, sine 0. And this is n cap. So it will be equal to sine 0 is 0, so it will be null vector. So null vector, as you are aware, its magnitude is 0 and possesses arbitrary direction, right? So the cross product of a vector with itself will always give us a null vector. Clear, friends? Okay, now what we'll do is, let's consider the cross product of unit vectors, right? So seventh is we'll discuss cross or vector product of unit vectors. I'm talking about I cap, j cap and k cap. Now look, students. This is suppose x-axis, this is y-axis, and this one is z-axis. It will be represented along this direction, right? This is the origin. As we are aware, x direction, that's represented by I cap, y direction, that is represented by j cap, and z direction, that is represented by k cap, isn't it? So I cap, j cap, k cap, these are the unit vectors representing the direction along x, y and z axis respectively. Now let's discuss their cross product. Consider I cap cross j cap. I cross j. So the orientation is to be measured from I to j. I to j. We are supposed to consider the rotation of I vector towards j vector. So it should be like this. Right? So what is the formula? Product of magnitude of I cap, product of magnitude of j cap, and sine of the angle between them. What is the angle between I cap and j cap? All are mutually perpendicular to each other. So the angle is 90 degree. So this one will give its magnitude. And what about direction? Let's fall back to right hand thumb rule. Look, friends. Angle is to be measured from I to j. That is in the anti-clockwise direction. So in the right hand, the fingers must curl in the anti-clockwise direction, as shown in the figure, like this. So thumb is pointing towards z direction. This is z axis, this is actually this one. So thumb is pointing towards z axis. And the direction of z axis is represented by k cap. So the direction of I cap is, and the direction of the cross product of I cap and j cap is k cap. That is along z axis. Am I clear, student? This will represent the direction and this term will represent magnitude. Now look, I cap cross j cap, it will be equal to the magnitude of unit vectors, the 1. Sin 90 is 1, so we will be left with k cap. So this is a very, very important result. Also, students, we have discussed, it is anti-commutative, therefore j cross I, j cap cross I cap, it should be equal to minus k cap. Remember, I cross j would be equal to minus j cross I. So it will be equal to minus k cap. It do not obey commutative law. A cross B is not equal to B cross A. A cross B is actually equal to minus B cross A. So using that concept, if I cross j is k cap, then j cross I would be minus k cap. Right? Okay. Now consider j cap cross k cap. J cross k. This is k cap, right? So consider this one. So as per the formula, product of magnitude of j cap and k cap, sine of the angle between them. What is the angle between j cap and k cap? Obviously it's 90 degree. This will give its magnitude. And direction, again we'll make use of right hand thumb rule. Look friends, this is k cap and the angle is oriented from j cap to k cap like this. So thumb is pointing towards the x axis whose direction is represented by I cap. So therefore it will be I cap over here. So what you get is j cap cross k cap. It will be equal to magnitude of unit vector is 1, sine 90 is 1, will be left with I cap. Right? Also, since as we have discussed, it is anti-commutative. Therefore, if we reverse the order, that is k cap cross j cap, it will be equal to minus I cap. So these are some very, very important results which we are discussing. Clear students? Now let's discuss k cap cross I cap. As was done in the previous steps, k cross I would be equal to magnitude of k, magnitude of I, sine of the angle between these two. This is k cap and this is I cap. What will be the angle? 90 degree. All are mutually perpendicular. This will give us the magnitude. And what about its direction? Students, look, this is k cap and this is I cap. So the angle is to be measured along this direction. Right? So it's like this. Angle is measured in the anti-clockwise like this. So thumb is pointing along y direction. So it will be represented by j cap. So what you get is k cap cross I cap. It will be equal to 1, 1, 1. Sin 90 is 1. So we will be left with j cap. So this is a very, very important result. And as it is anti-commutative, therefore the other result would be I cap cross k cap. It would be equal to minus j cap. So students, these are 6 very, very important results. Right? I'll tell you a simple method to remember these 6 results. Okay? Let's discuss that. So what to do is, suppose this is a circle and write I, j, k in the clockwise direction, the same order. Right? This is I cap, this is j cap, this is k cap. So clockwise, that is considered to be positive. So how to remember these 6 results? Now look, if it is taken in the clockwise direction, then the result will be positive. Remember, I cross j is equal to k cap, j cross k is equal to I cap, and k cross I is equal to j cap. Clear students? So we will obtain these 3 results. And if we consider in the anti-clockwise direction, suppose this is I cap, this is j cap, and this is k cap. Let's consider it in the anti-clockwise direction. Then what will happen is j cross I it's equal to minus k. J cross I is equal to minus k. K cross j is equal to minus I. And I cross k is equal to minus j. So in case of anti-clockwise, we'll get this result. In case of clockwise, we'll get these 3 results. Again, I repeat students. This is in the anti-clockwise, so it will be taken as negative. Right? Okay. Point is, I cross j is equal to k cap, j cross k is equal to I cap, k cross I is equal to j cap. Right? Now we will consider the anti-clockwise. I cross k is equal to minus j cap, k cross j is equal to minus I cap, j cross I is equal to minus k cap. So these are the sets of results which we will be obtaining using that concept. I hope you have understood the concept, students. Right? Okay. Now let's discuss another very, very important results. As students, we are aware the cross product of a vector with itself is always a null vector, because the angle between 2 equal vectors is 0 degree and sine 0 is 0. So what I mean to say is, so students, I cap cross I cap, it will be equal to magnitude of I cap, again magnitude of I cap, and since these two are equal vectors, the angle between them is 0 degree. Sin 0 is 0, so we will obtain 0. In the similar manner, j cap cross j cap, it will be also equal to null cap. Accordingly, k cap cross k cap, it will be also equal to null vector. The cross product of a vector with itself is always a null vector. Therefore, this is a very important result which we can conclude. I cross I is equal to j cross j is equal to k cross k, each is equal to a null vector. So these are some very important results of the cross product of unit vectors. Clear, students? So let's proceed with some other important properties of cross product, right? So what we do is, let us consider a vector and b vector to represent the adjacent sides of a parallelogram. Let us consider a vector and b vector to represent the adjacent sides of a parallelogram. So let's discuss this 8th problem. I am talking about this. This is suppose b vector. Let us consider this to be a vector. And let us consider theta to be the angle between the two vectors. As you are aware, students, the angle between the two vectors must be at a point where both the vectors must either emanate, that is originate, or at that point both the vectors must terminate. So that will be the effective angle, right? Here at point O both the vectors are originating. So theta is the effective angle between a vector and b vector. Now if these two are considered to be the adjacent sides of the parallelogram, then we can construct the parallelogram. It's like this. We can construct the parallelogram. Okay. In a parallelogram, the opposite sides are equal as well as parallel. This is a vector, this will be b vector. Now look, students, suppose the height drop a perpendicular. Suppose the altitude of this parallelogram is h, right? So what about the area of the parallelogram? Area of parallelogram is base multiplied by altitude. So what is base? The magnitude of base is b. Right, students? What is the altitude? That is the height of the parallelogram. It is h. Clear? Now, in this triangle, we can consider sine theta. This is a right angle triangle. Sine theta is perpendicular by hypotenuse. The magnitude of perpendicular is h. The magnitude of this hypotenuse is of a units, which implies that h is equal to a sine theta. Clear, students? Therefore, over here in place of h, we can write a sine theta. On rearranging, we can also write it like this, ab sine theta. And students, ab sine theta, it is actually the magnitude of the cross product of a vector and b vector. So it can be written as a vector cross b vector. So students, what we have proved over here is a vector cross b vector, its magnitude would be equal to the area of parallelogram formed by a vector and b vector. So this is a very important conclusion. So again I repeat this statement. The area of the parallelogram formed by the two vectors, a vector and b vector, is numerically equal to the magnitude of the cross products of a vector and b vector. Suppose the numericals a vector and b vector are given and you are asked to determine the area of the parallelogram formed by those two vectors. Then you are simply supposed to do the cross product of two given vectors and find its magnitude. So that is how you can obtain the area of the parallelogram formed by a vector and b vector. Clear, students? Now one more important thing. If you divide it into two parts, then area of this portion would be equal to area of the other portion. The diagonal of a parallelogram divides it into two equal parts, isn't it? So what about, this is a triangle. Again it is formed by these two vectors, a vector and b vector. So this is a triangle formed by a vector and b vector. And area of triangle is always equal to half area of parallelogram. So let's derive another very important result. So area of triangle formed by A vector and B vector, it is obviously equal to half area of parallelogram formed by A vector and B vector. Clear, students? This is the parallelogram. If we draw this diagonal, it will divide into two equal parts. Area of first part would be equal to area of second part. So area of the parallelogram would be equal to twice the area of the triangle. Or area of triangle formed by AB would be equal to half the area of parallelogram. That is what I have written over here. Therefore, area of triangle formed by A vector and B vector would be given by half area of parallelogram formed by A and B. And area of parallelogram formed by A vector and B vector is given by the magnitude of the cross product of A vector and B vector. That is magnitude of A cross B. So this is again very important result. So students, if A vector and B vector are given, then we can determine both the area of the parallelogram as well as the area of the triangle formed by the two given vectors. Clear? I hope you have understood the concept. So this was the 8th property. So let's proceed further then. We will discuss the area of a parallelogram when its diagonals are given, right? So that we can discuss. So 9th property. So here we will discuss if d1 vector and d2 vector are the diagonals, if they are the diagonals of a parallelogram formed by the adjacent sides A vector and B vector, then we will prove that area of the parallelogram is given by half the magnitude of the cross product of the diagonals of the parallelogram, right? So if d1 and d2 represent the diagonals of a parallelogram, then the area of the parallelogram is given by, then area of parallelogram having diagonals d1 and d2 is given by half magnitude of the cross product of d1 vector and d2 vector. This is what we need to prove. This is again a very important result which we can make use of in solving numericals associated with it, right? So let's try to verify this result. Let's consider a parallelogram. Suppose this is A vector. Let us consider this to be B vector. Let's complete the parallelogram, right? So this is the opposite side, they are equal. This is A vector. Don't forget to mention that arrowhead, right? It's absolutely mandatory to draw the arrowhead. These two are equal, so it is also B vector. This is one of the diagonal. This one. Suppose this is D1 vector. Now in this triangle, apply triangle law of vector addition. Apply triangle law of vector addition. So what do you get? Applying triangle law of vector addition in triangle 1, what we get is A vector plus B vector is equal to D1 vector. Am I clear, students? A vector plus B vector equals D1 vector. A vector, B vector, these are the two vectors representing the two sides of a triangle taken in the same order. So the vector resultant is given by the closing side of the triangle taken in the opposite order. So A plus B is equal to D1 vector. Clear? Similarly, triangle, this is suppose D2 vector. Consider this triangle. Consider this triangle. Right? Over here, what we get is, these are the two sides of the triangle taken in the same order. D2 vector plus A vector. These are the two sides of the triangle taken in the same order. A vector is from left to right. So in triangle 2, this one is triangle 2, this one. So in triangle 2, what we get is d2 vector plus a vector is equal to b vector. Look students, I am simply applying triangle law of vector addition. This one d2 vector and a vector. These are the two sides of the triangle taken in the same order, right, in the clockwise. So their resultant will be given by the third of the closing side of the triangle taken in the opposite order. So d2 vector plus a vector is equal to b vector, or a vector, or rather you can write d2 vector is equal to b vector minus a vector. Clear students? So we obtained both d1 vector as well as d2 vector. Now what to do is, let's cross multiply these two. So let us consider d1 vector cross d2 vector. Let's try to evaluate it, right? This is, remember, this is cross product. So what we get is, let's substitute the value. So d1 is a vector plus b vector cross d2 vector, it is b vector minus a vector. So what we get is, let's solve it. A vector cross b vector minus a vector cross a vector, a cross b minus a cross a, then b cross b plus b vector cross b vector, and then minus b vector cross a vector. Am I clear, students? So it is a cross b, this is cross product, a cross a, b cross b, it will be 0 or null vector. The cross product of a vector with itself is always a null vector, that we have discussed in the previous properties. So this is 0, this is 0. So you are left with minus b vector cross a vector. Now students, as you are aware, vector product is anti-commutative. A cross b is equal to minus b cross a. So what you do is, a cross b, it may be written as minus of a cross b. So what do you get? A cross b plus a cross b, isn't it? So what we get is twice a vector cross b vector. Therefore d1 vector cross d2 vector equals to twice a cross b, which implies that a vector cross b vector is equal to half d1 vector cross d2 vector. Still further, students, taking magnitude, what we get is a cross b magnitude is equal to half the magnitude of the cross product of d1 vector and d2 vector. And in the previous property, we have discussed the magnitude of a cross b, where AB represents the two adjacent sides of a parallelogram. This gives the area of the parallelogram. This is area of parallelogram formed by a vector and b vector. So it is equal to half magnitude of the cross product of the two diagonals of the parallelogram. So this is what we are able to prove. Right, students? So again, this was a very, very important property. So we have discussed lots and lots of properties. Now the last one. We will try to represent the cross product in terms of rectangular components, right? So let's discuss the last property, in which we will try to represent the cross product of vectors which are represented in rectangular components. And obviously we will be making use of the properties which we have discussed earlier. So, last one. Let us represent a vector and b vector, right? So let a vector is equal to axi cap plus ayj cap plus azk cap, and b vector will be represented by bxi cap plus byj cap plus bzk cap. Clear? Ax, ay, az, bx, by, bz. These are the components of a vector and b vector along the directions of x, y and z axis respectively. So what we are supposed to do is, we are supposed to find out the cross product of these two. So cross product of these two, it will be axi cap plus ayj cap plus AZ K cap. Cross. This is the cross product. It will be BX I cap plus BY J cap plus BZ K cap. Let's try to simplify it. So what you get is AX I cap, same term, that is AX I cap cross product, right? Cross of BX I cap plus BY J cap plus BZ K cap, right? Plus, let's consider the second term, AY J cap cross the entire term, that is BX I cap plus BY J cap plus BZ K cap. And last term, AZ K cap cross, again the same term, BX I cap plus BY J cap plus BZ K cap. Clear, students? Now let's solve it. I cross I is 0, so this first term gets eliminated, right? And in the second term, we get, these are scalars, it can be taken outside, AX and BY. Now I cross J, it is equal to K cap. You are already aware of it. Now these two terms, plus AX, BZ. I cross K, it's in the anti-clockwise direction. I cross K is minus J. Clear, students? These are the results which we have already obtained. Plus A1, BX, J cross I. It's in the anti-clockwise direction. So J cross I is minus K. Plus J cap cross J cap. It will be 0. So third term, that is AY, BZ. J cross K, that is I cap. Okay. Plus this term. This is AZ, BX, K cross I, it is J cap. This term, that is AZ, BY, K cross J, K cross J, it's in the anti-clockwise direction, so it is minus I. And last term, students, K cross K, it is 0 or null vector. So now let's try to rearrange these terms, right? Let's consider the coefficient of I cap. So what you get is AYBZ minus AZ BY and over here I cap, right? You consider these two terms. Then consider minus J cap. Minus J cap. So here what we get is AXBZ and over here this is plus. So minus has already been taken outside the bracket. So it will be minus AZ BX plus K cap. Okay, students, K cap. Over here we will get AX BY minus over here K cap. It is AY BX. So this is the result of A vector cross B vector. Clear, students? So it has been verified following the normal method. How to remember this result? It can be this result can be remembered if you write it in the determinant form, right? So you can also, for simplicity, you can also remember the result using this in the determinant form. This is I cap, this is J cap, and this is K cap. Now if you consider A cross B, then the coefficients of I, J, K of A vector is to be written in this column, right? So the coefficient of I cap of A vector is AX. Coefficient of J cap of A vector is AY. And similarly over here AZ. Then B vector, it will be equal to BX, BY, BZ. Here, students, I must mention, if it is B cross A, then write the coefficients of I, J, K of B vector in this row, and then consequently the second one, A vector. Clear? A cross B is not equal to B cross A. It is anti-commutative. So always remember, if the cross product of A cross B is to be found, then write the coefficient of A vector in the first row. Then write the coefficient of B vector in the second row. This is to be followed. So now you are aware of solving this. You will get the same result. Okay. I cap. So I cap. This into this multiplied by this into this. So what do we get? AY BZ minus AZ BY. Right? We are getting the same thing. In the central term, there is negative. You are aware of it. Okay. So we are left with these two terms and these two terms. This into this minus this into this. So what is left is AX BZ minus BX AZ. This is what we obtained over here. Isn't it, students? Last term plus K cap plus K cap. These are the four terms left. So AX into BY minus BX into AY. Right? So what we get is AX into BY minus BX into AY. So students, the result of A vector cross B vector in the rectangular components which we obtained over here can be easily remembered with the use of this determinant. Right? So while solving numericals, we'll follow this method. Understood, students? And what about the magnitude then? What about the magnitude of A vector cross B vector? Whenever any vector is represented in terms of I cap, j cap, k cap, that is the rectangular components, then its magnitude is given by square root of the square of the coefficient of I cap plus square of the coefficient of j cap plus square of the coefficient of k cap. Right? So here what we get is it will be equal to square root of what? The coefficient of I cap, that is AYBZ minus AZBY square plus the coefficient of j cap is this one, that is minus AXBZ minus BXAZ whole square. Right? It won't make any difference of negative. Square of negative is also positive. Plus coefficient of k cap, that is AXBY minus BXAY. So this one will give you the magnitude of the cross product of the two vectors A vector and B vector. Clear, students? Now students, lastly, if you wish to find a unit vector which is perpendicular to each of the vectors A vector and B vector, then how to find it, right? So that's the another very important result which we need to discuss before we end this session. So let's discuss the last point then. How to determine a unit vector which is perpendicular to each of the two given vectors, right? So 11th one. To find a unit vector, 11th point is to find n cap. N cap is perpendicular to both A vector as well as B vector. Now here we have to make use of the properties of the vector product. Now we are aware A vector cross B vector is equal to magnitude of A multiplied by magnitude of B sine theta and n cap. This n cap, students, it is perpendicular to the plane containing A vector as well as B vector, right? So we are supposed to find out n cap. Now look, students, let A vector cross B vector is equal to R vector. Then n cap represents the direction of R vector, isn't it? Therefore, R cap, which will be parallel to n cap, and R cap will be given by what? Vector divided by its magnitude. A unit vector is a vector divided by its magnitude. So what do we get? R vector is A vector cross B vector divided by its magnitude. So this is the master formula. R cap, it gives the result of n cap, and n cap gives the direction of A vector cross B vector. So if you wish to find a unit vector which is perpendicular to two given vectors A vector and B vector, then directly you can make use of this particular formula. A cross B divided by magnitude of A cross B. So this is a unit vector which is parallel to n cap, which in turn is perpendicular to the plane containing both A vector as well as B vector. So I hope students, now you must be feeling confident after doing this topic of cross product. So let me end this session now. In the next session we will continue with some numericals based on cross or vector product. Till then, take very good care of yourself and thank you. Bye bye.